everybody. So this is video 1 for parabolas. Before we start practicing problems, I just want to talk about the 4 different breakdowns that parabolas could be. In IM2, we just focus on parabolas that face up and face down. But now that we know about conics, we need to focus on the other directions as well. So with these, there's something, we need to find these 4 pieces of information for each parabola: vertex, focus, directrix, axis of symmetry. But you also need to know what kind of parabola it is. So that's what we need to know for type. So if I ever ask you what type of parabola it is, I'm asking, is it going to be vertical or is it going to be horizontal? After you've determined what type it is, you need to tell me which direction it's facing. So either up, down, right, or left. And I'm going to show you how to do that. So let's start with a parabola that's facing up. So it's missing a little bit of a diagram, so we're going to fill in together all the pieces. So we've got a vertex right there. That's the lowest or highest point. Oops, let me zoom in a little bit more. The vertex is the lowest point or highest point, or the point at which both tails of the parabola meet each other. We then have our focus and our directrix. The focus and directrix are both equidistant to the vertex. So let's say I wanted to put in my directrix right now. It's a line, it's not a coordinate. That would mean that my focus, whatever it's being pulled towards, is the same distance away. So I'll call my focus right here. So both the focus and the directrix are the same distance away from the vertex. So that distance is going to be called P. The absolute value of P is the distance between the vertex and the directrix and the vertex and the focus. So let's talk about what this means for all this information. As we've seen before, the vertex is still listed h comma k, so our x and y. So because we're just generally speaking and we're not actually doing pieces, or actually doing a parabola, let's just call vertex h comma k. The focus is going to be directly above the vertex, so that means the x value did not change, but the y value, or k, increased by a value of p. So whatever this coordinate was, it moved up the y-axis p units. Okay, the directrix is a line passing through the y-axis, so it's going to be y equals whatever the vertex is dropped down p units. So it's going to be k minus p. The axis of symmetry, I don't have it on here, but here, let me see if I can draw that in. Boop, 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 boop. You can kind of see it in green. That is passing through the x-axis right through the vertex on its h value. Okay, so we're going to have a point for vertex, a point for focus, and then we're going to have 2 equations of lines for the directrix and the axis of symmetry. So we're going to do this for all 4 types, and hopefully if you've seen it 4 times, it's going to get like burned into your brain. So I've got my vertex, whatever that might be, h comma k. If I choose to put my focus here, p units away, that would mean I gotta go the same distance the other direction to find my directrix. Okay, I've listed everything on there. Time to put it in here. So the focus is now underneath the vertex. So h did not change, but k dropped by units of p. If you compare that to the top one, the focus was above the vertex versus the focus being below the vertex. So that's why we have addition up here and subtraction down here. For the directrix, in this case, the directrix is above the vertex, so we're going to do y equals k plus p. Now, do you have to memorize all these? No. I'm trying to show you the deeper understanding, so like you don't have to remember when to use k minus p and k plus p, but thinking about it, if you know what your vertex is and it's facing down, the directrix is going to be above the vertex. So in this one would be axis of symmetry is still x equals h, because it's passing through the vertex, through the x-axis, on whatever the heck h is. All right, there's those two. We're basically repeating the steps for each one of these. So let's say it's facing the right. We are going to have, I'm going to put V for vertex. Vertex right there, so it's h comma k, whatever the point might be. Our focus is going to be inside the parabola. So if I put my focus there, how is that adjusting from the vertex? The y value did not change. From here to here, the y value is still k. But the h, or the x value, moved to the right a total of p units. So that's going to be h plus p. Then we have to do the same distance of p the other direction for our directrix. Which now is passing through the x-axis, so it's going to be x equals this time. And it's going to have the same y value as this, but it's going to have an x value of h take away p units. Now our axis of symmetry passes through the y-axis, so this one's going to be y equals whatever was the y value of the vertex, so it's going to be y equals k. This would be a good opportunity for you to pause the video and see if you can try to fill out this one on your own, and then resume the video to check your answers, if you wanted to do that. So this one we've got a vertex v at h comma k, wherever that might be. We are going to have a focus that is p units away. Excuse me. So our focus is going to be moving backwards or towards the left. So it's going to be h minus p comma k. And then we're going to do our directrix, which is the same distance p away. And it's going to go x equals whatever h was adding p. And the axis of symmetry is the same as the previous. Y equals whatever k is. Okay. So there's all the information. Highlighted in pink are the standard form equation of parabolas. That was on a previous slide. How do we determine whether or not it's up, down, left, or right? Well, this part, 4 times p, once we figure out what p is, that's going to tell us if p is positive, so it's bigger than 0, it's going to face up. If p is negative or smaller than 0, it's going to face down. Same thing with this. So if it's greater than 0, it's positive, so it's going to open towards the positive direction. I didn't write it down on this one. P is less than 0 or p is negative, it's going to face the negative direction. Okay, with that, let's practice some. I've got 1, 2, 3, 4 problems to practice with you. So let's do it. This is video 1, so we'll do 1A. Let's say we have y squared equals 6x, and that's it. I'm going to write up both types of equations on top just so we can keep referring to them. We've got x minus h squared equals 4p y minus k. And then we've got y minus k squared equals 4p x minus h. So the difference between these, this one on the left is going to be a vertical parabola. If the x is what's being squared, and over here is our horizontal if our y is being squared. Okay, so first thing to determine is the type and the direction. When we get better at these, you can kind of just tell from looking at it, but I want to kind of start by putting this in standard form so it's very clear what we're looking at. This one's y squared, so we're going to be following this. It's going to be y take away 0 squared, that would give us the y squared, is equal to 6 times x minus 0. So this piece relates to right here. So we need to figure out some stuff. We need to figure out what p is. 4p is 6 in this equation. So let's solve for p. If we divide by 4 on both sides, we get p equals, that reduces to 3/2, or 1.5. So we've got y was being squared, so it's horizontal. We have a direction, so p is positive, so it's bigger than 0, meaning that it's going to face the right. Cool. Let's talk about all the other pieces of information that we need. Vertex, focus, directrix, and the axis of symmetry. Oh, BKB. So the vertex is 0, 0, h and k. For us to find our focus for a horizontal facing the right, we're going to take our h and add p, comma k. So the k didn't change, so it's still 0 here. But we're going to add p right here to the 0. Let's do the directrix. Since it is going to be facing the right, or horizontally, we're going to have a directrix that's vertical. So it's going to be x equals p units away from the vertex. So it's going to be going to the left. So if we want to pull up a picture again. Our vertex is at 0, 0. We had a p value that dragged the focus 1.5 units to the right, then we got the p-value that's going to drag the directrix p units to the left. So it's going to be negative 1 and 1/2. Finally, our axis of symmetry goes right through the vertex. So that's going to be y equals 0, and that's my final. So let's plot all of our important information. I should be using graph paper, but I'm not. I'm being very bad. Oops. Okay, so should do it here too. All right, vertex is at 0, 0. We have a focus at 1.5, 0. A directrix at negative 1.5, so that is like right here. And there. I'm going to zoom in so you guys can see that a little bit better. So I did my axis of symmetry in green. My directrix is in orange. My focus is in blue. And then my vertex is in black. So, oh, I just realized I did that wrong. My bad. I'm not following attention to detail, am I? This is going to be horizontal. So I mixed up my x's and y's. That's okay. You gotta make mistakes as long as you catch them. The focus is at 1.5, 0, which is right here. So that's my blue dot. You know what? I'm just gonna go to graph paper because this is looking sloppy. Let's see, where's my graph paper? One A. All right, so we've got a vertex at 0, 0, a focus at 1.5, 0, which is right there, and a directrix at negative 1.5 through the x-axis. So that's right here. This is 1, 2. All right. And my axis of symmetry is right there. So I'm going to do this in pencil. We don't really know how steep it is, so we need to test a point. So I'm going to erase those. We could pick any point we want. Sometimes I put in x values, sometimes I put in y's. It doesn't really matter, whatever you feel is easiest for yourself. So let's say if my equation is y squared equals 6x, that was the original equation, and I wanted to do a test point at 2 comma something. That tells me at x equals 2, right there where my ruler is, I want to figure out what is the y value. So I'm just going to plug in 2 wherever I see an x, and then solve for y. So I get y squared equals 6 times 2. Y squared equals 12. Then I would take the square root of both sides. And I would get that y equals, where's my black pen? There it is. Y could equal about 3.5-ish. Type that into your calculator. I'm pretty sure it's 3.5 if you round. But it's going to be both positive and negative. Square root gives you 2 answers. So at x equals 2, it can go up 1, 2, 3.5 there, or down 1, 2, 3.5 here. So when I sketch my parabola, I now know it's going to pass through this point and this point. You got to test a point to make sure you know how steep to draw your parabola. Cool. There is 1A. I'm going to give you a problem to practice. Hold on, let me zoom out so you can see the whole thing. That was for 1A. There was all my info. I plotted the info and then I tested a point. Cool. 1B. So I'm just going to scribble out this. I'm going to use the graph paper from now on. 1B. This one's yours to try. X squared equals negative 8y. Cool. 1C. Cool. So why is this one different than that one? Well, this one had a center at 0, 0. This one's going to have a center at an HK coordinate. So let's list all the things we need to find. Type, direction, vertex, focus, directrix, and the axis of symmetry. So type, it depends on what's listed first. So this is x squared, so we go back up there. If x is being squared, we know it's going to be vertical. We don't know the direction, we're going to figure that out. We do know what the vertex is though. The vertex is the opposite signs of those. So this is going to be -1, -2. This 14 is in the 4p spot, so we're going to solve for p by going 4p equals 14. Divide by 4 on both sides, and we get p equals 14 over 4, or 7 over 2, or you could say this is 3.5. So p is positive, so it's bigger than 0. If it's bigger than 0, it's going to face up. I don't know why I put those dots there. That was stupid. Just ignore those points. Okay, so when we're thinking about this, it's going to have, let me do a quick sketch for myself. -1, -2. It's going to face up. So the focus is above and the directrix is below a value of p units. So focus. This is going to share the same x value, -1, but it's above, so we're going to add 3.5 to that -2. So if I do 3.5 plus -2, I get 1.5. So the reason why I'm doing this so quickly is because if you look at our notes, vertical faces up, it's going to keep the same h, but it's going to add a value of p to whatever k was. Okay. Directrix, it's going to go horizontally, so it's going to be y equals p units below the vertex. So I'm going to minus 3.5 and get negative 5.5. So I subtracted the 3.5 from the negative 2. Final step, axis of symmetry goes right through. It's going to be x equals whatever our h was, which was negative 1. Cool. Let us graph that. Okay, 1c. We are going to need a negative 5 and a highest point of like 2. So okay, let's do it. So we've got negative 1, negative 2 for our vertex. Our focus is at negative 1, 1.5. So that's going to be about right there. And then our directrix is at negative 5.5. 2, 3, 4, 5.5. All right, so as I mentioned in the previous problem, we don't want to just start graphing the parabola because we don't know how steep it is, so we should test a point. I'm going to, this time, test a point that is a y value, because last time I tested an x value. It doesn't really matter what you do. I'm just switching it up to show you another option. So let's say my test point, I'm hunting for an x given I'm testing 0 in for y. So my equation says x plus 1 squared equals 14, y plus 2. I'm going to plug in 0 where I see a y and then solve for x. So I have x plus 1 squared equals 14 times 0 plus 2. So 0 plus 2 is just 2. 2 times 14 is 28. And then we're going to either have, well, we have a square root both sides. The square root of 28 is about 5.29. But this is both a positive and a negative of that. So if I subtract 1 on both sides, we have x equals negative 1 plus or minus 5.29. So let's solve what those could be. X could be something, or x could be something for that coordinate that I'm testing. If I do negative 1 minus 5.29, I'm at negative 6.29. If I do negative 1 plus that, I get 4.29. Okay, so my 2 points now from up here is negative 6.29 comma 0 and 4.29 comma 0 are my two coordinates. And so we plot those. Negative 6.29, 1, 2, 3, 4, 5, 6, it's about there. 1, 2, 3, 4.29-ish. All right, so now that I know how steep my parabola is, I can connect in there. Cool. So that's all the math for 1C. I identified what type it was, what direction it's facing. I found these 4 pieces of information. I plotted them, then I tested some points to figure out what's going where. Time for your problem. One D. So that one's yours. I have 2 more to work with you, and then this video will be done. Moving on to 1E. Oops. Minus 3 equals x. So let me put the original format. So if it's vertical, we need x minus h squared equals 4py minus k. Or if it's horizontal, y minus k squared equals 4p x minus h. Okay, so 1E is not looking like our standard form. So we need to move junk around until we have it looking like standard form again. So we need to add 3 on both sides. And we don't want any number in front of the parentheses, so we are going to multiply everything by negative 10, the reciprocal of that, because then we would get negative 10 over negative 10, which is just positive 1, and then we don't need to write it. So we have y plus 2 squared equals, I'm going to leave this negative 10 on the outside. I'm not going to distribute it in because now it looks like that form. So type, direction, vertex, focus, directrix, and axis of symmetry. These are all the pieces of information we need before we can start graphing. Since y is being squared, it's going to be horizontal. Put HOR for abbreviation. So this is horizontal. The direction, we don't know, so we need to find what P is. This is in the P spot, so we've got 4P equals negative 10. Divide by 4 on both sides. It's still negative, but simplified down is 5/2. Or you can say 2.5. P is less than 0, that's negative. So that means it's going to be facing the left. All right, our vertex, we're going to change those signs. It's going to be, ooh, 3 goes to the x, so it's going to be negative 3, negative 2. I almost messed up. I almost put negative 2, negative 3, but since it's hk, h is right there. Okay, so let's think about this. I'm going to do a quick sketch of what it's going to eventually look like. At negative 3, negative 2, just like right here-ish, and it's going to face the left, which means my focus is inside. The focus is going to keep the same y value, but it's going to move p units to the left. So we're going to take this number and subtract out our p. So it's negative 3 minus 2/2. So we're at negative 5.5. Then we got our directrix, which is the same distance the other direction. So we are going to have it be x equals, because a vertical line passing through the x-axis, and it's p units away from h. So we're going to go ahead and add 2.5. So that would be negative 1/2. So if you're a little unsure, the directrix is going to be x equals h plus p. So that was x equals negative 3 plus 2.5. It's the distance of 2.5. Don't worry about that negative. That's what gets me here. Finally, our axis of symmetry is passing through the y-axis. So it's going to be y equals the k of our vertex. So it's negative 2. Good deal. Let us start the process to graph. Okay. This is 1e. One, two. Okay. I'm going to plot my vertex, which is at negative 3, negative 2, right there. My focus is at negative 5.5, negative 2. I'm going to do that in blue. 1, 2, 3, 4, 5.5. My directrix is x equals 1/2, negative 1/2, excuse me. All right, I've plotted, almost all that I can. I can plot in my axis of symmetry. But I need to test a point. I'm going to try testing, let's try testing what happens at negative 4. So I'm going to plug that in for x, and I'm going to solve for y. So if my equation is y plus 2 squared equals negative 10 times x plus 3, that was from right here, I'm going to plug in x and solve for y. Y plus 2 squared equals negative 10, negative 4 plus 3, y plus 2 squared equals, this is negative 1, right? Negative 4 plus 3. And if we multiply by negative 10, I get positive 10. So now I'm going to take the square root of both sides. Y plus 2 equals, square root of 10 is like a little bit more, I'm going to leave it alone. Square root of 10, I know it's going to be plus or minus, whatever it is. I'm going to minus 2 on both sides. Okay, now I'm going to type that into a calculator. I'm going to do negative 2 plus the square root of 10 and negative 2 minus the square root of 10. Do I have my cell phone to do that? Aha. Let's see here. Maybe. Okay. So we've got negative 2 plus the square root of 10 equals 1.16. Minus negative 5.16. Okay, so let's plot it. At negative 4, we have a point at 116. 1, 2, 3, 4-ish right there. And then we also have one at negative 5. 1, 2, 3, 4, 5, and a little bit more. So here is my kind of flat looking parabola. There we go. So there's all the math necessary for 1e. Give you 1f. Okay, this is the last one that I'm going to do. If you are drowning and you don't understand, go back and rewatch a couple of videos and see if you could pick up some stuff. There's no shame in going back and rewatching a video. I would strongly encourage you to do that. X squared plus 10x plus 4y plus 1 equals 0. Okay. We need to rearrange some stuff. I know I'm going to want to move that over here. So I've got x squared plus 10x. I'm going to leave some space to complete the square later. This is negative 4y minus 1. So completing the square, this becomes plus 25. We've done this enough to know how to complete the square. And then we've got, oh, don't forget to add 25 on this side too. 25. X plus 5 squared equals negative 4y plus 24. So we're looking good, but we want this to be in parentheses. So if we go back to the original up here, we want it to look like this. So I'm going to factor out a common factor between the two of these, which would be negative 4. So it's going to read x plus 5 squared equals negative 4 y minus 6. Because if I were to redistribute that negative 4 in, I would have that top line above. Cool. So let's talk about type and direction. Since x is listed first, this is a vertical parabola. We need to figure out about the direction. So here is the p spot. So we have negative 4 equals 4p. Divide by 4, divide by 4, and we have p equals negative 1. Since p is smaller than 0, or is a negative number, it's going to be facing down. Vertex, focus, directrix, and axis of symmetry. Those are the 4 things we need to graph. The vertex, we can see from the equation, it's going to be -5 comma +6, because there's my h and there's my k. I'm going to draw a quick sketch. It's not my graph, but I just want to understand what's going on. We have -5, 6. It's somewhere up here in quadrant 2. It's going to be vertical facing down, so we've got our focus is going to be somewhere inside the parabola. It's going to be p units down from the vertex. Since it's moving down, the x doesn't change, but this is going to go down by 1 unit, giving me 5. I misspelled the word directrix. Okay, then our directrix is going to be above on the outside, p units above, so that's going to still be -5. Directrix is an equation, not a coordinate. The directrix is going to go through the y-axis, so it's going to be y equals 1 unit above, so y equals 7. Our axis of symmetry goes right through our vertex, through the x-axis, so it's going to be x equals whatever h was. Cool. Let me grab some graph paper. And we'll graph this thing. It's going to be 1g. I know I have a highest point of 7, so I'm going to have a pretty high y-axis. So let's begin by plotting our vertex at -5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Then our focus, which is at -5, 5. Our directrix is passing through y equals 7. And our axis of symmetry passes through x equals 5. The more you do this, the more of a rhythm you're going to get. We need to test a point. I'm going to test y equals 4 and figure out what x is. How do I know when to test an x value or a y value? Well, the way I see it is if I take my pencil and I sketch the parabola. I don't know how steep it is, how skinny or wide it is, but I know at y equals 4, 1, 2, 3, 4, it's going to hit the parabola in 2 places. That's why I'm testing a y here. If I tested an x, like if I tested 3, it's only going to give me 1 point, but it's going to be easier for me to plot a parabola with 2 points, one on both sides of the vertex. So play around with it. Try both. Okay, so my equation was x plus 5 squared equals -4 times y minus 6. So I'm going to plug in 4 wherever I see a y. Four minus 6 is -2. X plus 5 squared equals, that becomes positive 8. I'll do the square root on both sides and get x plus 5 equals plus or minus square root of 8, whatever the heck that might be. And then I'm going to minus 5 on both sides. Now I'm going to go to my calculator and do this because I don't want to do that in my head. I don't think I'm even capable. I'm not that smart. Okay, let's clear that. So I'm typing both -5. Ooh, it's pretty bright on my screen. There we go. Maybe. -5 plus square root of 8 and -5 minus square root of 8. So we've got -5 plus the square root of 8. So I got x equals -2.17 or -5 minus the square root of 8. Okay. So we have these two coordinates that are going to give us a y value of 4. So about -217-ish right there. And then 7.8-ish right there. There is my parabola. Cool. All right, one more practice problem for you, and then this video is done. You guys made it. Proud of you. I know they're long. Not right. Y squared minus 16x minus 2y equals -33. I have misplaced my green highlighter. There it is. Okay, that one's yours to try. I want you to graph that parabola. Sounds like a game show. Graph that parabola. All right, bye guys.